A memory leak, this is when your program retains memory that it no longer needs. Your application crashes, so dangerous. Memory leak, memory leak, memory leaks in your applications. How to detect memory leaks? The memory allocation constantly increases. Take a memory snapshot, pull up the tab called retainers. In my case, this is a long-living RxJS subscription. However, this detached element, how to fix this kind of memory leaks, I will show you in the second part of this video in the next couple of weeks. So, welcome to the second part of this video series where you will learn what is a detached element, how they can impact performance of your application, and how to eventually fix them. If it is your first time on my channel, my name is Dmitry, and I help people to become advanced Angular developers by creating in-depth tutorials and courses. In the past, I have already covered quite a lot of advanced and unique topics in Angular. You can check it out later, but now let's focus on the topic of today's video. In the previous video, I showed you how to find memory leaks using the allocations on timeline and heap snapshot tools. If you haven't watched this video yet, the idea of the at least former approach is that you take an initial memory snapshot which shows what objects are currently allocated in memory. The next step is to change the state of your application and then immediately bring it back. Then you just repeat this action multiple times like I do by creating and destroying my widget component. And after that, you take another snapshot and compare it against the first one using the comparison mode. The idea is that any objects allocated for the dynamically created component are supposed to be released after the component is destroyed. For example, in Angular apps, very often leaking unhandled RxJS subscriptions. So, if we handled everything properly, we should not be able to find anything related to them. And as you can see, we have nothing here because we fixed those subscription leaks in the previous video on this topic. I would highly recommend you watching that video right after this one to learn more in depth about memory leaks, different strategies for finding and fixing them, as well as many other useful debugging tips. But let's continue. In that video, I ended up checking if the weather content component class instance had disappeared when its corresponding component was destroyed. And we didn't find it anymore, which is good, but we discovered this strange detached element which still remains in memory. Detached element might be a memory leak that happens when a certain element is removed from DOM, but still being referenced from your JavaScript code. I intentionally say that it might be a memory leak because not every detached element is actually harmful. For example, you might have something like menu or toolbar that is currently not rendered, but it will be rendered later. Otherwise, it might be considered as a memory leak and be potentially harmful, especially if the amount of this detached element grows or the element itself is quite big and you don't want to keep this everything in memory. My particular case is somewhere in between. On one hand, this leak is static. No matter how many times I create the widget component, there will always be only one remaining detached element as indicated by this delta value. On the other hand, we can assume that as application grows, this detached view might contain quite a lot of DOM nodes, right? And I might have also not one, but dozens of those widgets on the page. Therefore, the accumulated effect could potentially impact my application performance. So how do we find detached elements? One way, as you have already seen, is by using the heap snapshot tool and then just filtering by the detached keyword. And as you can see, we have a leaking detached element not only for the weather content component, but also for other things like app widget component, which by the way works as a simple wrapper where we eventually project particular components like weather content. But there is another tool that can help you with debugging this kind of memory leaks, and it is called Detached Elements. This one works in a similar way to heap snapshot. For example, you can clear everything and reload the page so that you have a clear initial state. After that, simply select this tool and take an initial snapshot. As you can see, there are no detached nodes yet. However, if we interact with our application by creating and destroying the components multiple times, and then if we take another snapshot, you can see that this time we have a few detached nodes. This tool gives you a nice general overview. You can expand a certain node to see the entire tree if you want, and also you can see how many nodes it contains. This tool is a great entry point for debugging detached elements, and it can show you their direction for further investigation. However, this tool doesn't show what the retainers of this node is. And to find out who the retainer is, you have to use the memory heap snapshot tool again. So just go and take another snapshot, and after that simply go and find the detached element you want to debug. And by the way, you can see that besides the detached DOM elements, the corresponding component class instance is also retained, and in a few moments you will understand why. Anyway, the next step is to focus on the particular detached element and pull up the retainers tab. As I said in my first video on this topic, this tab contains objects that are referencing the object you are actually debugging. And there might be many of them, and in this case I always look for something that is related to my code. And very often things I'm looking for, they're located at the top, and in my case here it is exactly so. As you can see, one of the retainers is the native element, which is a property of the element ref class. The element ref class is an abstraction over native DOM in Angular. And this element ref is being referenced by the location property inside the component ref class instance, which is then referenced by some private component ref property inside the app component. And this already looks like a part of my code. And here you can see the link which leads to the exact part of the code where this issue happens. And as you can see, when I create a widget component, I assign the reference to the dynamically created component to exactly this component ref property. And my problem is that when I destroy this component by calling the destroy method or by clearing up the view container, Angular destroys the DOM nodes for that component. But the instance of the dynamically created widget still retains, and exactly this reference prevents the DOM nodes from being completely removed from the memory, as well as the instance of the widget component itself. And before I show you a fix, I would like to quickly say that if you learned already something new from this video, you can support my efforts by hitting like to this video and subscribing to my YouTube channel to not miss my future Angular tutorials. Your support, this is the only thing that keeps me creating content like this. Thank you in advance, and let's see the fix. So in my case, to fix it, the only thing I have to do is to set undefined for the component ref property right after I destroy the component in order to remove reference from the component ref class instance. So in this case, the JavaScript garbage collector can remove it from the memory. If there are multiple places where the component can be destroyed, like in my use case, you have to either duplicate this logic everywhere, or you can explore the API of the certain entity you want to destroy and check if it has something like onDestroy hooks. The component ref fortunately has such option, so I can register the cleanup logic here inside the onDestroy callback. In such a way, you don't have to duplicate the code and you have one centralized place where you perform cleanup. Doesn't matter how exactly you destroy the component. And by the way, if you are curious how to dynamically create complex Angular components along with projected content, etc., I have a separate video where you can learn this topic more in depth. Anyway, now let's verify that everything works as we expect. So for that, let's clean up our previous profiles and just reload the page to pick the latest changes I made in my application. And after that, let's create and destroy a widget multiple times, and let's try to use the detached element tool to make sure that there are no detached element here. And also, if you try to make a memory heap snapshot, and if you try to find the detached element for widget component, you will not find it anymore because we have successfully fixed that memory leak. Before we go, I would like to quickly remind you that if you want to learn more about memory leaks and different strategies how to find them, please check out my previous video about this topic. It is really helpful. If you like this current video and you would like to thank me for it, the best way you can do it is to share this video with your colleagues and friends in your social media profiles, and of course hit like and leave your comments. Also, you can join channel membership program either here on YouTube or on Patreon to get early access to my upcoming videos and access to other exclusive and in-depth Angular content. And if you want to elevate your Angular skills to entirely new level, I offer a range of in-depth Angular video courses where I packed all my experience and covered such advanced topics like Angular forms, unit testing, and many others. Check them out as well, links will be in the video description. Otherwise, thanks for watching this video until the end. I hope you enjoyed this video, stay safe and see you in the next video.